G'day viewers, Alan here, welcome to my workshop. Been a bit distracted with other important things over the last few weeks, so haven't made that much progress with the Webster engine. But I have got a crankshaft and a Conrod now, and wasted my time making a flywheel, which isn't going to be any good, and some other stuff. Anyway, follow along and I'll share the journey with you and explain the bits that went well and the bits that went not so well. So I've made these bronze bushes for the crankshaft, pretty simple turning operation, and they're supposed to be a light press fit into the, well, I'm thinking that's a light press fit, and I'll probably call that a temporary install for the moment, and I'll come back for real later with a dot of Loctite. Okay, so I'm turning a blank for the crankshaft body here, and so I've got it turned to the correct OD of 46.23. I've drilled it for an and partially reamed it for 8mm. So I'm going to part this off now, and then I'll turn it around in the chuck and do the other side. Must be getting pretty close. There we go, and I'm not going to touch that because I'll be pretty confident she's very warm. So I flipped this around in the chuck, and I now have to machine this face into the centre to leave a 12.7mm diameter boss in the middle, and that will become a thrust face for the crankshaft. Now, because this disc is only held by the absolute tips of the jaws, I was using this as a safety measure just in case it came flying out of the chuck. So we'll just put that back in and get started on doing this reduction of the face to create the boss. Because the grip on this thing is so tentative, I'm taking very light cuts. I'm only required to go in 0.8 anyway, so essentially I'll do 4.2mm depth of cut passes. So that's my blank for the crankshaft. So that'll be the central, the hole for the central shaft, and then I've got to shape this and put another pin over here for the crank pin. But I will see if I can just break these edges ever so slightly. Don't have much room to move here. Really don't have much wiggle room here. Yeah, I think we got it. I just have to clean this up a little bit by hand, but I did actually get the worst of it off. Alright, now let's finish the turning part of this deal. We'll get this out of the chuck. So, it wasn't being held by much. Okay, so I've brought the disc over from the lathe and put it on the milling machine. Now all of the features that I've got left to do, which is the hole which you can see I've already done here for the crank pin, and the slices off the, shall we say, off the sides here, they can be located in relation to the central hole. But to do that I need to be able to rotate this and translate it in both X and in Y. So what I did was, I don't have a mini pallet which I'd made for this rotary table, but I do have this plate which I made from a bandsaw, and it's got an array of 8mm tapped holes. I also have these guys which I made for another project, little clamping plates, but they have 6mm holes in them. So I made these little hold down pins, I suppose it's called them, and they're 8mm thread on one end and 6 on the other. I just had some of these bolts out of a 2-stroke motor and I just cut them in half, and well, actually I turned this down to 6mm, cut it in half and then thread it and made these. So these let me clamp this into position. I've got little brass strips here to avoid marking it. I've drilled and reamed this to 6mm, and I've got a 6mm dowel pin here, so I can push that in there. Now I've got the hole done. It's a pretty firm fit, but I can press it in like that. One other point that I didn't make, I don't know whether you'll be able to see, but there's a clean surface there. Before I did any operations, I had this, this is a bit of scrap aluminium just bolted to the plate to raise this up off the plate, but it also allowed me to machine that top surface to guarantee that the surface of the plate here is perpendicular to the axis of the milling machine, the quill. Right, anyway, so this pin will stop this thing from rotating, and obviously the clamps will hold it in position. So now the issue is how to, on this piece is sacrificial, but the issue now is how to cut these side pieces off, how to locate to do that. And I could have probably worked it out mathematically, but I decided to use the capability of the CAD software. I'll be rotating the body about 20 degrees about that centre point, and then I need to know what the offset of the cut line is from what will be my y-axis. So what we'll do is rotate this thing in the package 20 degrees, and now what I want to know is the distance from there to there. Well, we'll put a bit of construction geometry, or a phantom line if you like, through there, and that tells me that that line is perpendicular here, which is what we need. Now I need to know how long the line is. 12.67mm. That's it, job done. So I've got to rotate 20 degrees about that axis and then offset 12.67mm. Let's get to it. Okay, so I've repositioned these two clamp plates. Probably don't need them actually. Now I've got the dowel in here and that bolt through there. This can't move around at all anyway, but they're there, they can't do any harm. So I've put this vertical pointer in here just so I can track the intended path of the cutter and make sure it doesn't hit anything. Well, that looks alright. The pointer is actually on the cut line, so I have to move over half the diameter of the end mill. Okay, so I've got a 6mm end mill in there, so I've got to add 3mm to the offset. So I'm going to do 2 3mm deep passes and leave myself a clean up margin, so I'm actually coming over at 15.8. Let's see how that works out. Alright, so I've roughed that down, but I think now I was thinking I'd do this to a rough size and then that to a rough size and get a check measure across, but I don't think the outer dimensions are actually that critical, so I'm just going to go with that. So I'm going to machine this down to its final dimension now. Well, let's finish cutting both sides. Now I've got to get sorted for the nose radius. Okay, so I've repositioned these toe clamps up the back here and moved this whole plate and assembly back so that the dowel pin here, and I actually engaged the dowel pin because that's a 6mm cutter with a 6mm collet. I was able to put that collet straight over that dowel pin and get that hole centered under the center line of the quill, which was quite convenient. So now when I rotate the rotary table, we're on the correct centre of rotation for this nose rounding. Drawing calls for that radius to be 7.24, so I've just got to move the table back to the rear, 7.24. We should be good. I think I might finish it by hand from here. It's a bit hard to see exactly how much has to come off, but I certainly don't want to go too far, so I think we're going to finish that by hand. There was a given dimension for this thing on the drawing across these points of 3703, and I think we just managed to get that. I've managed to stay in the picture. Okay, so I'm ready to assemble the crankshaft and to start off by Loctiting the crank pin in, hopefully. There's a pretty good fit in the hole. Well, let's see how we go. For better or for worse, that's it. Wipe the excess off. It's looking pretty neat on the bottom there anyway. So I don't know whether it's already got well enough that I can do the other piece or not. Well, I'll leave it overnight. Okay, so I've got a crankshaft now. Seems to turn pretty smoothly. It's just running in plain bronze bushes. So I've got a piece of 6061 aluminium. It's a 100 wide bar, I guess you'd call it, and I'm going to chop a little piece off the end here to make the Conrod. I know this is 12 thick, but I thought it would get through a little bit easier than that. Anyway, keep going. Well, there's my bit. Ah, the bloody thing moved. That's what was going on, and I was cutting around in a corner. Damn it. So I'm not sure whether this piece is going to be useful. I will be able to use the piece I cut off, but let's see if I can just straighten this up. That's more like what I was expecting to get from the cut. Anyway, so that squared the end up, and like I say, the piece that came off will be useful, because it being a Conrod, one end's obviously for the big end and the other end's for the little end. Right, well, we'll put this piece to one side for the moment. We'll come back to it when I cut a piece off for the making the rocker arm. Okay, well, I've cleaned my blank up on all four sides, and this will be the final cut, hopefully bringing it to 8mm thick. I say hopefully because I don't seem to have the same luck with hitting exact dimensions with the milling machine that I do with the lathe, and I'm never quite sure why, but anyway, fingers crossed, we're shooting for 8mm thickness. Alright, time to get my homework marked. 8:01 at that end. About the same at this end, within the accuracy that I can measure to, but I'll call that 8mm. Like I said, don't usually achieve that level of accuracy with a milling machine, so charmed for this one. Okay, so I've got to drill a hole for the big end bush and another hole up here for the little end bush. Bit of tape there is an attempt to stop the shavings from marking the surface. Probably wasting my time, but anyway. There's the idea. Oh, hopefully that's a 3/8 diameter hole. Well, here's a 3/8 dowel pin. That's a pretty good fit. I think we can call it a 3/8 hole. Close enough anyway. And 249. Yeah, 249 goes in as well. So, yeah, we must be very close. So I reckon that would press in without any trouble, but I don't really. Just starting. Think maybe it's because I haven't managed to get this full depth. I think I'm going to leave well alone. I could press that in, but I'm making the bush up to go in there anyway, so we'll leave it alone. Oh yeah, we'll leave it alone. Okay, so that's done. It's time now to move this over to a jig that I've got in mind to do the rest of the machining. Okay, to explain the process I've got in mind for making this piece of aluminium into Conrod shape. Actually, the process is a similar concept to what I did for the crankshaft. I'm going to mount it on a bit of sacrificial material or a temporary piece on the rotary table, and I'll be able to work, I think, all of the features from the centre of that hole. So I've got 2 1/4-inch holes here, because I've got to have a 1/4-inch hole up this end, and the idea is to clamp it on there. These specially made screws. And I made a mistake initially, or I overlooked something, so I made this screw up. Yeah. Anyway, it was I don't know, 3/8 or thereabouts diameter that I turned down to create the 1/4-inch and a locating shoulder, a locating feature, and it worked really quite well. It's quite a good fit. But I overlooked one thing. The milling cutter that it's not quite. Oh, it's just in view. The milling cutter that I want to use isn't long enough to reach past the height of that head. I could have wound it down a bit, I suppose, but I decided in the end just to make a different fastener. And I've got this made this little brass. I don't know what you'd call it. Rotary shim. I don't know. Insert anyway, and using countersunk head 1/4-inch screw. So I've put 1/8-inch holes at each of the 4 inflection points where the curve on the end transitions into the line along the side to try to get a nice smooth transition. That's the plan. Right, so now I can start doing the milling. Let's just see where we've got to here. Yeah, got a bit further to go. About there, I think. That's actually done quite a neat job, because I actually went slightly oversized, meaning to go back the other way with climb milling to clean it up, but looks like that isn't needed. I think I'll go back, I don't know. We're set up for it now, so. That looks pretty good. Okay, so I'm going to start cutting some off the side here now. I'll do it in a couple of passes, I think. And I'm going to start away from the inflection point a little bit. Oh, my piece is under there somewhere. So now we can do our climb mill back that way to final pass. So get positioned here correctly, and this should be taking a very light climb mill cut. My maths has worked out correctly. There's plenty of room for doubt about that. No, it doesn't look like I allowed enough cleanup, does it? Started to do it, but obviously the cutter wandered around too much. Alright, we'll have to take a little bit more off to get it cleaned up. Well, that has cleaned it up a bit. Disappointing though. So I'm now 0.3 undersized on this side. Don't really want to take any more than that because I have to do the same on the other side to balance it up. So I guess where I went wrong was being too aggressive in the cuts and left the cutter wandered off too much and left a very rough finish. So perhaps I should have gone only half depth. Alright, I'll do the other side. Okay, so I've done both sides and machined around the little end and finished off the top surface with a recess of 0.79, and I'm now at the point where I ruined my first one. Oh no, I set 0 from this face and it should have been 0 from the, let's just ruin this piece. Yeah, not happy about that. Anyway, so we'll set it up to machine the other side here and hopefully not mess it up. So the drawing calls for the sides of the Conrod to be recessed down 0.79. That's what I'm set up for here, so I'll do one loop around here and go over to there, and then I'll have to rejig so I can rotate around that point. But where I went wrong with the previous one was resetting 0 incorrectly, so I must remember that top surface is 0 and I'm going down 0.79. Yeah, it's all looking good, so just have to flip it around in the jig now so I can rotate around this point. Okay, so I'm going to call that done. Trying to make all of these different cuts line up perfectly is a task beyond me, but I think I'm going to be fairly close. In any case, it's the best I can do. So that's this piece done. I'll move on now to making the bushes, which will be the little end and big end bearings. Okay, so I'm going to press the big end bearing into the Conrod now. I've made it a 1.5 thousandths interference fit, so it'll take a bit more than finger pressure to get it in, but I don't think it needs Loctite. quite a bit of push needed there. Right, so it's got the big end bearing done. It swings around pretty freely. So a bit more progress. Let's get on to the little end bearing now. Ready to press the little end bearing in. It probably doesn't need Loctite again because I've made it a definite push fit, but we'll put a drop on there. Can't do any harm, can it? And being a smaller diameter, there's just less to grab hold of. That's quite hard pushing that in. I'll keep going now, I suppose. Loctite definitely wasn't needed there. There's a really firm press. But that's alright, not a problem, better than being loose. But anyway, Conrod with big end and a little end bearing. Okay, that's got it all assembled, and it all sort of fits together. Unfortunately, whilst the piston's free to move through that short arc, as soon as we start getting any angle on the Conrod and putting a bit of side loading on the piston, it all turns to something smelly. I think the issue is that the bore isn't smooth enough, and we generate too much friction on the side of the piston. Pretty sure that's what's going on. Because again, once it's come to that position, the piston will move backwards and forwards a little bit, but it's just not interested in going past that. So, as I say, pretty sure there's too much friction on the side of on the piston skirt. Yeah. So I guess I'm going to have to revisit the finish on the bore. From this angle you can see the oiler tube for the wrist pin, so at least I got that right. Well, as I said in the intro, some progress, but also some trod on some snakes in the game of snakes and ladders. Clearly what I've got to do from here is refinish the bore of the cylinder, probably using diamond lapping, and I have bought some diamond lapping paste to do that, as recommended by my friend Matty of Matty's Workshop. Only thing is I don't know how to do it yet, so I'll have to work out how to make a lap and have some fun doing all of that. Anyway, that's for the next episode. I hope you enjoyed this one, and I look forward to seeing you on the next one. Cheers.